Welcome back, friends. In the previous session, we discussed about mass spectrometry and we saw the examples about mass spectrometry. I hope you enjoyed the session. And in the session, we are going one step forward, starting discussing about the atomic models. So this is one step forward. I hope you will enjoy the session and everything will go well for you. So about atomic models, these are just the ideas of different peoples about the structure of an atom. Dalton alivyosuggest kuhusu structure of an atom ambao tulisoma kwenye session ya kwanza, walikuja scientists wengine ambao walikuwa wana suggest different things about the structure of an atom. Baadhi yao ndio ambao walifanya discoveries about atomic particles, lakini baadhi yao they didn't discover anything, but they were just modifying what others they have said about the structure of an atom. So in atomic models, we are saying that atomic models explain how electrons, protons and neutrons are arranged inside an atom. So how electrons and protons and neutrons, they are arranged inside an atom. So the discovery of subatomic particles posed another challenge to earlier scientists in determining the actual structure of an atom. After the discovery of the electrons, protons, and neutrons by different scientists, then the question came, how are these subatomic particles, they are arranged in the nucleus or they are arranged in an atom, and how an atom is. Okay, Dalton suggested that an atom is the spherical body, the visible spherical body. But later they come knowing, or they come with the knowledge that the atom is divisible into electrons, neutrons, and protons. So now the question comes, how are these electrons, protons, and neutrons arranged in an atom? So what is the structure of an atom? How an atom look like? So among the earlier scientists to explore atoms structure, we had J.J. Thomson, which we have discussed him in discovery of electrons. Then we have we had Ernest Rutherford, and then we had Niels Bohr. These are the scientists who described the atomic structure, the earlier one. So we'll start discussing by this, the Thomson model of an atom, Rutherford, and then the Bohr. How are these scientists, they discuss about the structure of an atom? And then later, after discussing these three scientists, we'll discuss other things regarding the structure of an atom and different suggestions regarding the structure of an atom, which were suggested after a number of time. So we are saying that these scientists attempted to understand the actual structure of an atom based on the Dalton's atomic theory. So hao walikuwa wanaenda kwenye series, sio wote walifanya kazi kwa pamoja. J.J. Thomson ndio alikuwa kwanza, yeye alisuggest kitu. So kuanzia kwenye Dalton, J.J. Thomson alienda hatua moja mbele. J.J. Thomson alisuggest kitu chengine mbele. Kutoka kwa J.J. Thomson, Ernest Rutherford akaenda hatua moja mbele kutoka kwa Thomson. Lakini pia kutoka kwa Ernest Rutherford, Bohr akaenda hatua moja mbele. Niels Bohr akaenda one step forward. So kila scientist alikuwa na fight mpaka akili yake ilipoishia, then scientist anayefuata anaendeleza pale ambapo mwenzake ameishia. So this approach led to the development of the concept of the atomic structure as described by the following model. So the first model to be discussed is the J.J. Thomson atomic model. J.J. Thomson atomic model. J.J. Thomson atomic model. J.J. Thomson atomic model. Now let's see first about the experiment of J.J. Thomson, and then finally about what is suggested about the structure of an atom. We already discussed about the J.J. Thomson experiment, about the discovery of electrons, and he was the first person to discover that atom is atom is indivisible, because he was the first person to discover subatomic particles. Before J.J. Thomson, kilichokuwa kinaaminika ni kwamba atom is indivisible according to how Dalton alisuggest. So J.J. Thomson alifanya the great effort to know that the atom is divisible. J.J. Thomson suggested the plum padding model or the resin padding model of an atom. This is called the plum padding, or sometimes the resin padding model. Tunaposema plum pamoja na resin is just like the same thing. You know, majina ya hizi experiment sometimes yalikuwa nalingana na real things which are happening in our environment. So when we are talking of the plum padding, plum ni kama chakula fulani. Kuna chakula kinaitwa kabisa plum. So unakuwa ni kama mkate fulani. Ule mkate unatengenezwa is like wanapotengeneza keki za happy birthday. Zile keki ukiziangalia kuna vitu wamevichomeka hivi. Wamevichomeka kwenye ile keki ya happy birthday. Unaona? So a plum ni kama ile keki yote. Inaitwa nini? Plum. Or sometimes it is called as raisin. So ile keki ambayo imetengenezwa kwa ngano na mixture different substances, certain food ambacho ni kitamu ndio kinaitwa plum. Lakini kutoka kwenye kile chakula kuna vitu vimechomekwa. Vile vitu vinaitwa nini? Padding. Vinaitwa padding. Kwa I know mfano wa keki happy birthday au keki anyway, unaweza kuchukulia kama ni keki ya harusi, keki ya sherehe anyway, lakini to me keki happy birthday is the best example. So kutoka kwenye ile keki tumechomeka vitu ambao vile vitu tulivyochomeka kutoka kwenye ile keki vile vinaitwa kama padding. So tunakuwa tuna keki kama hii hapa. Hii ndio keki. Let's say this is our cake. And from this our cake tuna vitu ambavyo tumevichomeka. So vimeingia hadi huku hivi vitu. Vimeingia hadi huku hivi vitu. Tumevichomeka hapa. So from here hii keki yenyewe ndio inaitwa kama nini? Kama a plum or raisin. A plum or raisin. For your own time, you can go to Google the plum or raisin. For your own time, you can go and then you can see the diagram for Google. You know, our teaching technique is still like analog. It's not digital, so we can't Google photos and you can see photos here. There is no such accessibility, so it is impossible for me to show photos and just explain to you what you will see. This is a plum, or sometimes it is called a raisin. And these are called as the padding. They are called as the padding. So that's why this model of an atom is known as plum padding model or raisin padding model. We are saying that raisins are sweet, dry grapes. Actually, they are not grapes kama grapes. Kwa sababu grapes ni maepo. Grapes ni maepo. And finally, raisin, they are not grapes as grapes we know, but ni kama kamkate fulani. Ni kama, the best example ni birthday cake. We can call it the raisin. So raisin are sweet dry grapes which can be spread on a bread cake as raisin padding. So tunakuwa tuna hivi vitu ambavyo tunaweza tukaziweka kwenye nini? Kwenye keki. Unaona? So unaweka cake au bread, then kwenye ile bread au kwenye keki hapa juu unaweka hivi vitu. Unaona? So this model is called the raisin padding, or is called the plum padding model. The distribution of raisin on a cake, that means raisin padding. Distribution of raisin on a cake, raisin padding, au plum padding. Yani plum umewekea padding. Distribution, unaelewa? Distribution of raisin in a padding or distribution of plum in a padding is similar to the distribution of electrons in an atom. Kulingana na J.J. Thomson anachokusema. And the distribution of seed in some fruits such as watermelon. Watermelon, that is the best example. If you don't know watermelon, I don't know Which category of a person are you? Umezaliwa wapi? Haujui tikiti maji. Tikiti maji. Okay, I don't have tikiti maji here, but I know most of you know tikiti maji. In structure, the tikiti maji is like this way, and then always in tikiti maji you can see seeds ziko inside, like this way. You will see the diagram of tikiti maji well in my notes, but this is how. So I don't have tikiti maji here. Sorry for that, I have not come with that the practical tool to teach you. But the distribution of seeds in the tikiti maji, in the watermelon, distribution of seeds. These are the seeds distributed in the watermelon. Distribution of the seeds in the watermelon is similar to the distribution of electrons in an atom, according to J.J. Thomson. So he said that the electrons, they are distributed in an atom, like how the seeds have distributed in the watermelon. And this model is what we call the plum pudding, are related to the distribution of electrons in an atom, as suggested by J.J. Thomson atomic model. So according to J.J. Thomson, kwa sababu unaweza kuuliza swali kwamba uandike J.J. Thomson atomic model, utasemaje? According to J.J. Thomson, an atom can be considered as the large positive charged sphere like padding in which electrons were embedded like plums in a padding. So an atom can be regarded as the large positively charged sphere like padding. So this positively charged sphere, we call it as padding, which represents an atom in which electrons they are embedded. So electrons they are embedded, these are the electrons. Kwa kulingana na J.J. Thomson, hivi ndivyo ambavyo atom inaonekana. Ni hivi kulingana na J.J. Thomson. So hii ni sphere, this is the sphere of positive charge. Sphere of positive charge. Sphere of positive charge. So some diagram you will find that the positive charge iko hapa katikati. Wamechora kubwa ili uweze kuona kwamba imejidistribute kwenye sphere zote. Lakini baadhi ya michoro utakuta positive charge na zenyewe zimejidistribute kwenye hii sphere. So this is the sphere of positive charge. Positive charge zimejidistribute ziko ndani. Hivi ndivyo ambavyo J.J. Thomson alisuggest. Lakini the best example for watermelon is a very good example. I know all of you know about tikiti maji. So about tikiti maji is the best example of the J.J. Thomson atomic. The total positive charge in that positive sphere is evenly or systematically balanced by the negative charges in electron, and the whole atom remaining neutral. This model was called a plum pudding model or raising pudding model of an atom. Raising pudding model of an atom. Kwa hiyo utaona diagram hapo ambayo itakuwa inakuonyesha tikiti maji pamoja na Thomson plum pudding model. So according to Thomson, he summarized the idea of Thomson can be summarized as: first, the atom is full of some positive fluid. It's like atom imejaa positive fluid kama uji. Fluid can be gas or fluid can be liquid. So mimi nakwambia fluid, tunaashumu atom ni kama imejaa uji fulani, uji. Hapo ndani ya ule uji, ya kwa wale ambao umesoma ya shule fulani za government, ndani ya ule uji umekatia bagia mle, au umekatia kitafuna fulani. Okay, you know, sometimes it is good to just memorize some of the phenomena ambazo tumepitia. Unakuta kuna uji ambao hautaki kuunywa bila kukatia vitu. So it's like that way. It's just an atom like a sphere, and in that sphere kama ball tumeweka porridge ndani. tumeweka polar. Baada ya kuweka porridge mle ndani, finally tunaweka nini? Tunakatia bagia. So those bagias, they are just like electrons inside the sphere having porridge. I know these examples, they will be commonly and they will be familiar to you, so that it will be easier for you to understand the mode of an atom. So an atom is full of positive fluid. Then electrons are embedded in that positive fluid. The total positive charge is equal to the total negative charge of electron in an atom. About the success of Thomson atomic model, it is true that the total positive and negative charge in an atom, they are equal. So an atom, it is neutral. That is true. So if it is true, that means hiyo ni success. Lakini pia the J.J. Thomson model paves the way kwa wanasayansi kuanza kudiscuss about the structure of an atom. Manake without J.J. Thomson hakuna scientist ambaye angetaka kudiscuss zaidi. Lakini alipofanya yeye, alifanya kama wao influenced wapate hamasa zaidi ya kuweza ku think more about the structure of an atom. About the limitation, shortcomings or failure of Thomson atomic model. Shortcomings or failure, they are many. Kwa nini? Kwa sababu yeye ndio alikuwa wa kwanza, kwa alifeli mambo mengi. Wenzake kila wanapogundua wanamkosoa kwa bwana, pale ulifeli. But don't fear. Hata wewe ukifeli kama ndio wa kwanza, au wewe alifanya mtu, wewe umeanza pale kama umefeli, don't you worry. Kama ndio wa kwanza, you must fail in order to teach others that nilifail pale. You know, we know the histories of Thomas Edison. He conducted experiments 999 he failed, and in 1,000 times he succeeded to light a bulb. So don't you worry, failing it's not mean that you have failed everything. Kwa sababu gani? Hata alifeli, lakini mpaka leo his name is in the books, and we are studying about the J.J. Thomson atomic model. So first he tried to explain how these subatomic particles were arranged. Alisema tu kwamba positive charge ziko kama sphere, electrons ziko embedded kama seeds in watermelon. Yani, he was not specific at all. And then the second, the model did not explain why electrons and protons in atom do not neutralize each other. Kama electron na proton ziko tu zimejipanga tu, yani sina mpangilio, kwa nini zisi neutralize? Yani kwa nini zifanye reaction fulani mle ndani? Kwa nini? Akuelezee. Tatu, according to the laws of electrodynamics, electrons in Thomson model should lose energy by radiation. Na ziki lose energy, nini kitatokea? When they lose energy, therefore they would eventually to a hole in a positive sphere. Kwa sababu tunaposema positive, sisi huko remember tunapozungumza structure of an atom, chemistry na physics vinaingiliana sana. So positive huwa tunaligadi kama sphere. Tukiwa tuna atom kama sodium, tukaiondoa electron, tunaligadi kama hii positive kama nini? Sphere. Ni kama hole, ni kama mtobo ambao ile electron tuliyoiondoa kwa sodium, kama haitapata energy fulani, ile electron itarudi kwenye ule mtobo. Unaelewa? Itarudi kwenye ile hole. So according to the laws of thermodynamics, ni kwamba hizi electron kwa Thomson model zinge lose energy, and after losing energy, therefore they would eventually fall to a hole in a positive sphere. So they would eventually fall to a hole in a positive sphere. Lakini limitation nyingine, Thomson atomic model failed to explain how the positive charge holds on the electrons inside the atom. It failed to explain about the stability of an atom. Kwamba zile positive charge zinazishikaje negative. how the atom is stable. How the atom is stable, and the Thomson model failed to explain about that. Then, the theory did not mention anything about the nucleus of an atom. So it did not mention if an atom had a nucleus or not. And finally, we are saying it was unable to explain the scattering experiment of Rutherford. Scattering experiment of Rutherford. Now we have discussed a lot about the J.J. Thomson model and the success, also limitation of the J.J. Thomson model. In conclusion, we are saying that this model was rejected since the model could not explain the experimental results. So different experiments ambazo zilifanyika ikiwemo hiyo ya scattering experiment by Rutherford, J.J. Thomson alishindwa kuelezea. Na tutaenda kuona kwamba according to J.J. Thomson scattering experiment ingekuwaje. Now let's move to Rutherford atomic model, which is the second atomic model. Rutherford's atomic model. So, in order to understand the arrangement of electrons and the protons in an atom, Ernest Rutherford and his students in 1990 performed a series of experiments. I am not sure if this 1990, I think it is 1890. So, yeah, let's look here. However, I know this is not the time for correcting things, but it's better if I put you with the correct things. I put you with the correct things. So it is 1890, it's not 1990, it is 1890. Rutherford and his students. So in 1890, 1890, Rutherford pamoja na wanafunzi wake performed a series of experiment known as Rutherford scattering experiment, au wakati mwingine naita kama ni alpha particle scattering experiment. So the alpha particle is positively charged particle. Alpha particle, they are made up of helium-2, 4, and they are positively charged particle. These are positively charged particle. They are positively charged particles. So the alpha particle are positively charged particles. Now, tuone Rutherford alifanya nini? Na alipofanya nini aliona kilitokea nini? Kwenye experiment ya Rutherford alifanya kitu ambacho ni simple sana. Remember, alpha particle they are positive particle. Alifanya kitu ambacho ni simple sana. Alichukua alpha particle ambazo mimi naweza nikachora hapa. Nikasema hii hapa ilikuwa ndo sheet, akaweka radium hapa katikati. Alipoweka radium akachukua alpha particle. Hii alpha particle alielekeza kwenye atom. So atom ilikuwa hapa, ambaye atom ina nucleus. Japo yeye alipokuwa anafanya experiment alikuwa hajui kuwa na nucleus, ila alichukua hizo alpha particle akazidirect hapo kwenye atom. Now remember, this alpha particle, they are beam. That means it consists of many rays. Ziko nyingi hapa. So tukiweka hivi hatuna maana kwamba ni alpha particle moja, ni beam. Ziko nyingi hapa zinaenda. Now kilichokuwepo ni kwamba kutoka kwenye hii atom, some of alpha particle, yeye huku pembeni aliweka kitu ambacho kinaweza kikadetect kama mwanga umepita au hujapita. So aliweka material huku, ambayo material ilikuwa mwanga ukipita mwanga, hii material ina fluorescence. So kuna mwanga umetokea. Kuna mwanga umetokea. Ina fluorescence. Kwa nini? The reason for fluorescence nishaelezea sana jana. Kwamba hizi particles huwa zinatransfer their energy kule. Kwa hiyo baadhi ya hizi particles zilizopita huko pembeni zilionekana zimefika kule. Kuna fluorescence. Particle iliyopita hapa ilionekana imefika. Kuna fluorescence. Lakini particle kwa mfano iliyopita kama hapa kulikuwa kunaonekana imebend. Fluorescence imetokea kule. So why particle nimedirective? Zile za kule zimetokea wapi? Sababu nilitegemea hizi particles zote nizo direct hapa. Zikienda hivi straight. Nilitegemea fluorescence itokee kuanzia hapa hadi hapa. Fluorescence ya huku inatokea wapi? Fluorescence. Sasa kilichokuwa hapo manake akaanza kujua inawezekana kuna kitu hapa katikati hapa kinasababisha bendi hapa. Lakini later unaona hii ni kama small deflection. Later kaona kuna nyingine ambazo zinakuwa deflected zaidi. Hii tunaita ni large angle deflection. Lakini nyingine ambazo zilinyosha kabisa hapa katikati hazikuweza kupita, zikarudi. So some particles they bent with the small angle, or they deflected with the small angle. Some particles they deflected with the large angle, and some of them they go back, or they were reflected back. Cause deflection. Sasa parata pole akaanza kujua the alpha particles they are possibly changing. And in this atom Brother Thompson alichokisema hapo, Brother Thompson alisema kwamba hii atom ni sphere of positive charge na electron humu ndani. Brother Thompson alichokisema humu ndani positive charge zimejidistribute tu na electron humu ndani ziko tu vile. Hichi ndicho ambacho Brother Thompson alikisema, na according to Brother Thompson itakiwa alpha particles zote zipite according to none? To Brother Thompson. So according to J.J. Thompson, itakiwa all alpha particles zipite. This is expected results. Manake rather for the kufanya experiment, expected results was this one, but the observed results were this one, which was the scattering of alpha particle. So what caused the scattering of alpha particle? It is because we have positive charge in the nucleus, and the alpha particle they are positive charged particle. So the positive charge in the nucleus and the positive charge in the helium, they tend to repel each other. Positive charge of alpha particle and the positive charge in the nucleus, they repel each other. And finally, the result of this repulsion of the positive charge in the nucleus and those in the alpha particle is the deflection of the alpha particle. So the explanation for this experiment, tunasema kwamba in the experiment they bombarded a target of atom with alpha particle by subatomic projectile. So these projectiles called the alpha particles were obtained from a radioactive substance, and for our case walitumia a radium. In this experiment, a piece of radioactive substance, which is radium, ambayo ndio hii hapa, ilitumika katika kutengeneza alpha particle. So in this experiment, a piece of radioactive substance, which is radium, is placed in a lead block. This is the lead block. Kwa nini hii kwamba isilete effect hiyo radium? Is placed in a lead block. The block is constructed in such a way with slits that only allow beam of alpha particle to escape. So here we have slits which allow the alpha particle to escape in one direction. And because the alpha particle they are raised, so they will escape on in that direction. The stream of high energy alpha particles was directed to a thin gold foil, cause ilielekezwa kwenye thin gold foil ambayo ilikuwa hapa, ambao kwenye hii thin gold foil inside it tuna nini? Tuna nucleus. Kwa hiyo actually Rutherford didn't understand about the nucleus, about an atom, but what he understood is that gold foil is made up of atoms. So zilipelekwa kwenye thin gold foil. Then in order to detect the alpha particles after scattering, a movable circular screen ambayo ni hapa, movable circular screen iliwekwa hapo. Movable circular screen, or sometimes it's called the fluorescence detector, coated with zinc sulfide, is placed around the gold foil. So when the alpha particles strike the zinc sulfide, these produce the flashes of light which could be detected. Kwa alpha particle ikigusa hii hapa, kuna mwanga unatokea ambao unajua kuwa kuna alpha particle kule. So by examining different portions of the screen, it was possible to detect the proportion of alpha particle which got deflected through various angles. He expected that the alpha particle would just pass straight through a gold foil and could be detected by a photographic plate. Expectation of Rutherford experiment was like this way, because this is what was done by Bohr. This was the expectation, but the observation was different. Kama ambavyo tunaenda ku discuss hapa, observation was different. So about the observation of the Rutherford model, first, what he observed, most of alpha particle penetrated the gold foil. Most of alpha particle penetrated the gold foil and deflected and produced tiny flashes of light at the point where they hit or they stuck, indicating that atoms are mostly empty. Most of alpha particles zilipita. Unaona? Nyingi zilipita. So nyingi zilipita. Most of alpha particles they pass through and they cause flashes on this screen. Lakini ya pili, some alpha particles were deflected through small angles and a few were deflected through large angles. So some alpha particles were deflected through small angles and a few were deflected through large angles. Baadhi zilikuwa deflected kwa angle ndogo na baadhi zilikuwa deflected kwa angle kubwa, indicating that atoms consist of concentrated center of positive charge. Kwa nini? Kwa sababu hii positive charge it repel the helium, which are alpha particle. Lakini observation ya tatu, very few particles completely rebound on hitting the gold foil. Very few particles completely rebound. They completely rebound. Cause they rebound on hitting the gold foil. Very few of them they rebound on hitting the surface. So kama Thomson model ingekuwa ya kweli, electrons zote zingepita kama hii diagram. So tunachosema ni kwamba if Thomson atomic model was correct, the large positive sphere could have offered little resistance to the passage of alpha particle, even though there were also positive charge. This is because alpha particle move at high speed with high momentum. Even though there would have been some repulsion due to like charges, the momentum would have overcome the repulsive effect and the particle would have deflected slightly or gone straight through. For according to Thomson, hizi particles zote zingepita au nyingine zingekuwa deflected kidogo tu. Lakini kwa nini zingine ziligo back? Now we must think out of the box. What was here? So interpretation of the Rutherford's observation. Kwamba Rutherford observation alichokiona kilikuwa kina maana gani? What Rutherford he observed, what does it mean? So the fact that most of alpha particle passed straight through the gold foil without any deflection show that there is a lot of empty space in an atom. Kwamba kwa sababu alpha particle nyingi zilipita, inaonyesha kwamba the most of alpha particle ni empty. Ni nini? Ni empty. A lot of space in an atom, it is empty. Lakini ya pili, the volume of nucleus is very small compared to the volume of an atom, so that many alpha particle pass undeflected. Volume ya nucleus is very small. Yaani kwa diagram yangu hapa nimechora kubwa sana. I will be proposing to draw is the volume of nucleus. Lakini ya tatu, the deflection of some of the particle indicate that there is a center of positive charge in an atom. There is a center of positive charge, and this positive charge repels the positive charge of the helium or of the alpha particle. This center repels the positive charge particle as well as deflecting them away from the original path. So the positive charge center of mass in an atom is called the nucleus. So Rutherford was the first scientist to suggest about the presence of nucleus in an atom. The positive charge of nucleus is due to the presence of the positively charged particles called the protons. So protons are found in the nucleus of an atom. That's one among the conclusions that Rutherford made. The fourth observation is that the rebound of alpha particle on hitting the gold foil shows that there is a center of mass which is very dense. Sio tu positive, ni positive lakini pia ni very dense. Very dense maana kitu kikiwa kigumu, it's not easier for the particles to pass through it. It is very dense. Lakini things, it is simple, maana it is very easier to pass through it. So hiyo ilimpelekea Rutherford kupostulate au kuwa na ideas. We have many ideas. Yani hizi observation, experiment, all of these, they are questions which can be asked in the exams. So now let's discuss the postulates or the ideas of Rutherford atomic model. So according to Rutherford, firstly, an atom consists of extremely small, dense, positively charged particle called nucleus. Kama tulidiscuss kwenye observation pamoja na zile vitu ambavyo walikuwa wamesema kutoka kwenye observation. So conclusion ambazo tunazopata, an atom consists of extremely small, dense, positive charged particle called the nucleus, where the entire mass of an atom is concentrated. Some of learning materials or some of books utakuta wameweka hizi hapa kama ni postulate mbili tofauti. Postulate ambayo nasema ni atom consists of extremely small, dense, positively charged particle called the nucleus itakuwa ni kivyake, na pia postulate nyingine itakuwa ni the entire mass of an atom is concentrated in the nucleus. Lakini mimi nimeweka kama postulate moja. B, an atom consists of negatively charged electrons revolving in a fixed orbit around the nucleus. So according to Rutherford alisema kwamba atom pia ina electron ambazo zina revolve around the nucleus. Alisema zina revolve around the nucleus according to Rutherford. Akasema we have electrons revolving around the nucleus in orbit. And then the third idea of Rutherford, he said most of the space in an atom between the nucleus and the revolving electrons is empty. So according to Rutherford, alisema most of the space between the nucleus and this revolving electron is empty. Most of the space between the nucleus and the revolving electron is empty. So hicho ndicho ambacho Rutherford alikuwa amekisema hapo. Rutherford alikuwa amekisema. Now let's see kwamba hii ndo ambayo Rutherford alisema. Manake that means hapo tutakuwa na revolving electron, then hapo tutakuwa na empty space. This will be our nucleus. Now let's see about the success and shortcomings of Rutherford. Other features of the model, there are other features of the model, yani other ideas. Kwa mfano, positive charge of the nucleus is due to protons, and the magnitude of the positive charge on the nucleus is different for different atoms. Hizo ni other ideas, lakini main ni zile tatu. Kuna nyingine ambayo nucleus is surrounded by negatively charged electrons which balance the positive charge, that the atom is electrically neutral. Kwa pia Rutherford alikuwa anakubali kwamba electrically an atom is electrically neutral. Lakini pia the electron are not stationary but are revolving around the nucleus with a very high speed, like planets revolving the sun. And that these electrons are called planetary electrons. Na tutaenda kuona kuna kitu kinaitwa Rutherford's planetary model of an atom. Yani electrons they are revolving around the nucleus is how planets they are revolving around the Earth. And then the electrons and the nucleus are held together by electrostatic force of attraction, which we discussed it from yesterday. We said it is called the centripetal force. So centripetal force is simply the electrostatic force of attraction, which tend to pull the electrons towards the nucleus and which tend to hold the electrons, ambayo inahakikisha electrons hazitoki pale kwa nuclear attractive force. So pia tunayo Rutherford planetary model ambayo yenyewe according to this model electrons are revolving around the nucleus just as the planet revolves around the sun. So according to a Rutherford planetary model, maana tunakuwa na nucleus, then you have electrons revolving in orbit. This is according to Rutherford. But this doesn't actually happen in real life, and that's not actually happening in atoms, as how we shall discuss later as we are continuing with this session. And from there, let's see about the success and the shortcomings or the drawbacks of Rutherford. About the success of Rutherford, it is true that an atom has the center, which is nucleus, and the whole mass of the atom is concentrated at the nucleus. So Rutherford's model of an atom successfully explained the charged nature of an atom, but it could not account for the whole mass of an atom. So haikuelezea the whole mass of an atom, lakini ilielezea the charged nature of an atom, kwamba kwa nini atom inaweza kawa charged. It is because electrons zinaweza katoka. Lakini pia alielezea kwamba positive charge iko concentrated in the nucleus. Hizo zote ni ideas ambazo zilikuwa ni true. But about the shortcomings of Rutherford, pia kwa sababu Rutherford ilikuwa ni mwanasayansi wa pili, shortcomings zilikuwa nyingi. Kwanza hakuelezea kwamba revolving electrons zingeweza emit energy by electromagnetic radiation. And when they emit energy by electromagnetic radiation, they lose energy continuously. So finally they would fall into the nucleus. That means here we have the nucleus and we have the revolving electron. So let's say a revolving electron iko hapa. Sasa according to Rutherford, hii revolving electron ingeweza ku lose energy. As it revolves, it loses energy. As it revolves, it loses energy. As it resolves, so in a revolve, in a lose energy. And finally, ingeenda kutua pale kwenye nucleus. So this according to Rutherford, kwamba he failed to explain about the stability of an atom. Kwamba why electron yenyewe inapita kwenye orbit moja tu, haiji kufall kwenye nucleus. So revolving electrons would emit electromagnetic radiation and lose energy continuously. The electrons would therefore ultimately fall into the nucleus and the atom would collapse. Thus, this model suggests an unstable picture from the atom, and hence it was not acceptable because it failed to explain the stability of an atom. To summarize this failure, we say it failed to explain the stability of an atom. The second failure of Rutherford, the model could not explain the emission of electromagnetic radiation accompanying stable atoms and the existence of spectral lines. Ilishindwa kuelezea kuhusu emission of electromagnetic radiation by atoms. Kwa hiyo kwamba how emission of electromagnetic radiation inaweza katokea, either an atom can absorb or can emit energy, it didn't explain. And then the third shortcoming of Rutherford, the planetary model could not explain the phenomena of photoelectric effect. What is photoelectric effect? We discuss it later, not in this session, but in the continuing session. We discuss in detail about the photoelectric effect and other phenomena associated with it. From there, let's move to the final atomic model which we are discussing, which is the Bohr atomic theory. The Bohr atomic theory, or you can call it the Bohr atomic model. So, after the experiments of J.J. Thomson and Rutherford, Bohr also came up with the theory of the structure of an atom. So he was the last scientist to suggest about the structure of an atom. Later, there came scientists who suggested different things about an atom. But on the structure of an atom, Bohr was the last to suggest the structure of an atom. So after his exploration and the propositions of atom, Niels Bohr in 1912 put forward a picture of the atom. He solved the problem of the instability of Rutherford atom and gave a complete explanation of the emission and absorption spectra or radiation by electrons. So huyu Bohr ndiye ambaye alitoa explanation about spectrum, lakini pia aliweza kuelezea kwamba Rutherford he failed to explain about the stability of an atom, but Bohr he succeeded to explain about the stability of an atom. Bohr referred to Max Planck quantum theory, which we will discuss it later. The Max Planck quantum theory, according to which energy can be absorbed or emitted in a certain amount called the quanta. So energy can be emitted or absorbed in a certain amount called in certain packets like. So the amount of energy can be measured in terms of number of quanta. We discuss it in the Planck's quantum theory, and then we will see a lot about the calculation of the amount of energy by using quanta. So energy can be absorbed or emitted in certain amount like separate packets called the quanta. In a certain amount like separate packets called the quanta. So Bohr suggested that an electron moving in an orbit can have only a certain amount of energy and not infinite number of value. Energy is quantized. That means MVR is equal to 2n divided by hm. 2n divided by hm. This is what we are saying, that the electron revolving in the orbit of an atom, its energy is quantized. Is quantized manake inategemea na hii orbit. Hii tunaita principal quantum number. Inategemea na principal quantum number ya orbit ni ngapi. So as it depends on the principal quantum number, as the principal quantum number increases, also the energy of an electron increases. So tena kuona many things about the energy of an electron na vitu kama hivyo ambavyo Bohr alifanya calculation and he derived about an atom. So tunachoweza kwenda kudiscuss sasa hivi, Bohr alidiscuss vitu vingi, radius of an atom, energy of electron in its orbit. Like now let's discuss about the postulates of the Bohr atomic theory. Postulates. Yani Bohr yeye alisema nini in his idea? What did he postulated? What did Bohr postulated in his idea? First, the electron revolving around the nucleus in a circular permissible orbit. Electron revolves around the nucleus in a circular permissible orbit. And when they revolve in this orbit, they do not radiate energy. So we have the nucleus, and then we have the electrons revolving in the orbits. And there are different orbits. So when an electron revolves in this orbit, it doesn't lose energy. There is nuclear attractive force tend to pull this electron, and this nuclear attractive force provides what we call the centripetal force, which tend to maintain the motion of electron around the nucleus. But what we are saying about this is that when it revolves around this orbit, it doesn't lose energy. That means if the electron lose energy, lazima ishuke. Ikishuka ndo energy yake inabadilika. That is to say, the electrostatic force of attraction, between the electron and the nucleus, providing necessary centripetal force which allow the electron to move. So we have the centripetal force. Nisema centripetal force inakiwezesha kitu kiweze kumove kwenye circle. Kwa hiyo tunapokuwa na circle yote, yani mduara, we must have centripetal force ambayo ina-ensure kile kitu kina move kwenye circle. So according to Bohr, these orbits on which the electrons revolve have specific energy. The energy of these orbits is quantized, as I shall discuss later. Because of possession of the same energy, orbits were called the stationary states. Kwa nini? Kwa sababu electron ikiwepo pale, energy yake remains stationary. The energy of electron doesn't change. However, the electron itself revolves, but the energy of an electron doesn't change. So states in which the energy of electron is constant, that's why they are called as stationary, because the energy of electrons is constant when they are there. This is because electrons are moving in the same orbit in which energy is the same. And there is a definite quantity of energy which is associated with each stationary electron, which we are using the formula. Energy of an electron is equal to negative 13.6 electron volt divided by the principal quantum number n square. This is the, here there is no square. This is the formula which is used to calculate the energy of an electron in its orbit. For energy electron, En ni principal quantum number ambayo ni orbit. Kama hiyo orbit wa kwanza anakuwa ni K, huyu ni L, huyu ni M. Yaani huyu ni energy level namba 1, namba 2, namba 3. So namba 1 N anakuwa 1, namba 2 N anakuwa 2, namba 3 N anakuwa 3. Principal quantum number, we discussed this idea of the principal quantum number in the later sessions. So the term stationary states does not mean that electrons are stationary, but it means that the energy of electrons does not change. This accounts for the stability of an atom. So this first postulate of Bohr simply solved the issue of stability of an atom, which was not solved by Rutherford. From there, we are saying that the angular momentum of an electron in stationary state is quantized, and it is an integral multiple of h divided by 2 pi. So sorry, I failed to memorize well this formula. Initially I told you it is h divided by hm. I told you it is 2n divided by hm. Now listen to me. The angular momentum of an electron in its orbit, it is quantized, and it is an integral multiple of h divided by 2n. So divided by 2 pi. So manake angular momentum, kwanza angular momentum ni kitu gani? Nikuelezee kwanza kuhusu angular momentum. Momentum is equal to mass times velocity. Lakini electron ana move kwenye circle, ana move kwenye mduara. So how do we get the angular momentum? Kama electron ana move kwenye circle, that means angular momentum, it will be equal to mass times angular velocity. Asa angular momentum ambayo ni sawa na mass times angular velocity. How do we get this angular velocity omega? Angular velocity omega is equal to velocity linear times the radius, which is r. That is to say, angular momentum is equal to mass br. This is the expression for the angular momentum. And from the angular momentum, now we are saying angular momentum mbr is quantized, and it is an integral multiple of h divided by 2n. That means angular momentum value yake for a certain energy level n, the value of angular momentum mbr will be equal to n times h divided by 2 pi. So maana yake ni kwamba kwa energy level fulani yenye value ya n, angular momentum is an integral multiple of h divided by 2 pi. So that is to say, in other words, angular momentum mvr is equal to n h divided by 2 pi. This is the formula ambayo tunasema kwamba the angular momentum of an electron is quantized. We are using this concept to say the angular momentum of an electron is quantized. And here, h is the Planck's constant and n is the principal quantum number. E pi ni ile 22.7, m ni mass electron, v ni velocity electron, linear velocity, r ni radius. R hapa ni radius of the orbit of an electron. That is the second postulate. The angular momentum of an electron in its stationary state, it is quantized. So from there, number 3, electron can jump from one orbit to another, and when it does so, it emits or absorbs energy. Electrons can jump. Electron ina uwezo kujump, ikatoka 2 ikaenda 3. So according to how Bohr he suggested, that means ni kama vile hapa tuna this line. Hii line iwe ina represent increase in energy. So here tuna first energy level n is equal to 1, tuna second energy level n is equal to 2, tuna third energy level n is equal to 3, tuna fourth energy level n is equal to 4, then tuna sixth energy level n is equal to 6, and then tuna seventh, na huko mbele kutapelekea tunachokiita convergence limit. Kwa hiyo huku juu baadaye huku juu kutakuwa kuna kitu tunakiita the convergence limit. So from there, hapa electron can jump from here to this energy level, but also electron can jump from this orbit to this energy level. So hapa maana yake ni kwamba inategemea kama huyo electron mwanzo alikuwa kwenye energy level n is equal to 1, ili aweze kwenda energy level n is equal to 2, lazima absorb energy. So this include absorption of the energy. Lazima to absorb energy. Au in other words, lazima huyo electron ambaye yuko hapa tumfanyie illumination. So tukimuilluminate atom with light, huyo electron akiwa knocked hapa ana uwezo kuabsorb energy na akawa excited kwenda energy level hiyo. So in this system of an atom, we call this as the ground state. We call it as the ground state. Ground state maana ni pale ambapo electron inakuwa imekaa normal kwenye state yake ya kawaida. So ground state sio lazima iwe ni moja, inaweza kuwa ground state yake ni hapa, ground state ni hapa. Kwa mfano, electron iliyoko kwenye shell ya 3 kwenye element yote, ile ndio ground state yake. Lakini on supplying heat or on illuminating an atom, electron inaweza kujump kutoka pale kwenye energy level ya 3 ikaenda juu zaidi, au electron inaweza fall down. So kwenda juu zaidi tunaita excitation. So hapa tunapaita kama ni excited state. So the ground state ni ile stable condition of an atom, of an electron pale ambapo imekaa kawaida. Tukiilluminate au tukisupply energy, electron inapanda kwenda excited. Sasa excited sio lazima ifike hapa tu. It can be excited even to the 6th energy level. You see, it depends on the amount of energy ambayo tumesupply. So tukisupply amount of energy kidogo, electron itakuwa excited hadi hapo. Lakini tukisupply large amount of energy, electron can be excited mpaka pale kwenye 6. But also, when the energy of excitation is greater, the electron can exceed convergence limit. Now, what is the meaning of convergence limit? Convergence limit, hii ni point ambayo electron ikifika haiwi inavutwa tena. Remember, hii ni N1. Yaani maana hii ni sawa sawa na hii shell. Hizi tu tumeziweka kwa line. Kwa nucleus iko. Hii nucleus ina pull electron. Electron ikifika hapa kwenye convergence limit haivuti tena na nucleus. Kama haivuti tena na nucleus, maana yake electron inakuwa imeshatoka kwenye nuclear attractive force. Na tunasema in this case an atom will become ionized. An atom will become ionized. So electron inatoka ground state, it can be excited to any energy level ya juu. Lakini if it exceed convergence limit, an atom is ionized. Na energy inayotumika kutoa electron kutoka kwa ground state mpaka kupitiliza convergence limit, yani kupitiliza nuclear attractive force, we call the energy as the ionization energy. Kwa sababu electron ikishatoka kapitiliza convergence limit, hawezi kurudi tena kwenye ground state. Na kama hawezi kurudi, that means an atom is ionized. The energy used to ionize an atom, we call it as ionization energy, which is different in different atoms, kwa sababu the nuclear attractive force in different atoms is also different. Lakini from there ni kwamba kwenye electron ikitoka hapa ikija hapa, let's say this is our excited state, n is equal to 2. In this excited state, electron always is not stable. So kama sio stable, ikipata tu chance ina lose energy. Iki lose energy, ina fall back to its ground state. So electron inaweza absorb energy, ikawa excited kwenda kwenye other energy level. Tunasema ina jump to other energy level. When it jumps to other energy level, it absorbs energy. But when it falls back from the other energy level, it falls back, it releases energy. So here there will be energy released. Energy will be released. Energy will be released. So here energy is absorbed. When it jumping to higher energy level, is absorbed. When the electron jump to higher energy level, but when it jump from higher energy level to lower energy level, it releases energy. It releases energy. So when an electron jump from orbit of higher energy level to orbit of lower energy level of an atom, it emits energy in the form of electromagnetic radiation. A quantum of radiation is called as photon. What is quantum and what is photon? We discuss them in detail when we be discussing about the Planck's quantum theory. When we be discussing about the Planck's quantum theory. So the energy emitted is equal to the difference. As we know that electron in its energy level, it has energy. So kwa mfano hapa tunaweza kusema energy huyu hapa ni energy labda tuko E1, energy hapa ni energy 2, hii hapa ni E3, hii hapa ni E4, hii hapa ni E5 and hii hapa ni. Kwa hiyo kama tulivyosema kwamba the electron in its orbit it has energy. If the electron in its orbit it has energy, that means tukitoka hapa ikijump kwenda hapa inahitaji kuabsorb energy. Hapo ni sawa na difference hapa. Hapo tutasema change in energy ni sawa sawa na energy 2 minus energy 1. So ikitoka hapa kuja hapa ita absorb amount of energy ambayo ni sawa sana. Ikitoka hapa juu kushuka hapa ita release or ita emit amount of energy which is equal to this amount. Kwa hichi ndio kipimo cha energy ambayo either itakuwa absorbed or released during electron transition. And according to Planck, akaja kusema kwamba hiyo energy hii hapa change in energy ni sawa sawa na h divided by ni sawa sawa na hc, ni sawa sawa na hc divided by wavelength, au ni sawa sawa na hf, ambayo f ni frequency. Sometimes you tunatumia v. All of these facts we discuss them in detail later. What you need to understand here is that electron can jump from one energy level to another. When it jumps from higher to lower energy level, it tends to release energy. When it jumps from lower to higher energy level, it tends to absorb energy. Number 4, an atom consists of a small, heavy, positively charged nucleus in the center, surrounded by electrons. The electrons in an atom revolve around the nucleus only in certain selected circular path called the orbits, about to shall discuss. Hizi zinaitwa nini? Orbits. Na kazi kwa sababu huko mbele tutadiscuss vitu vinaitwa orbital, sio orbit. So hapa tutakuwa na kitu hichi kinaitwa orbits. Hizi zinaitwa orbits. So one ni orbit, nyingine ni orbits. Huko mbele tutadiscuss kitu kinaitwa orbital. orbital. Ndani kwenye orbits, within an orbit we have subshell. Within a subshell we have orbital. It's like rooms. Yeah, within a large house tunakuwa tuna small rooms, and then small rooms we may have small rooms again. So unaweza kukuta kule kwenye small rooms kabisa kule ndo ambako electron huwa zinaenda kujifichaga kule. Hizo small rooms tunaita orbital, but we will discuss them in detail later. Don't miss, because the orbitals, discussion of the orbitals is to almost at the end of this topic. So don't miss. Things will be enjoyable kuona jinsi gani electron zinajificha kule ndani kwenye small rooms of the orbits. So the orbits are associated with definite energy and they are called energy shells or energy levels. Kwa hiyo orbits zinaitwa energy levels. Kwa nini? Kwa sababu energy hapa na hapa na hapa ni tofauti. So that's why they are called as energy level. These are numbered as number 1, 2, 3, 4 from nucleus. Or alternatives, they are given later as K, L, M, N, and from there tuna continue na alphabet kama kawaida. Kwa hiyo hizo ndizo assumption of the Bohr atomic theory. About the achievement of the Bohr atomic theory, we can't explain them more because some of them need you to learn about the hydrogen spectrum, and after learning about the hydrogen spectrum and the derivation of different formulas, itakuwa ni easy ya kuelezea achievement of the Bohr atomic theory. Bohr alifanikiwa vitu vingi sana. Kwanza hapa tunasema aliweza kuelezea hii formula 1 divided by wavelength ni sawa na RH, then 1 divided by 1 square minus 1 divided by 1 divided by 1 square divided by 1 minus 2 square. Aliweza kuelezea hii formula. Sio tu aliweza kuelezea, aliderive hii formula. Hii formula imetoka kwenye zile formula za energy of electron ambayo sawa negative 13.6 electron volt divided by n. Lakini hata hii nayo aliderive hii. Bohr aliderive hii energy of an electron, aliderive. Sasa najua tukiderive hapa, tutakimbiana. Na mimi sitaki kufundisha vitu ambavyo out of syllabus. Tukiderive hapa tutakimbiana. Kwa baadhi ya watu sema tutakimbia. General chemistry ndio muhimu. Hapana, sio hivyo. So he managed to explain this. We call this as the Rydberg equation. Lakini pili, he managed to calculate the radius of hydrogen. Alicalculate vipi? Tena kuona huko mbele formula aliyotumia. Then he explained about the hydrogen spectrum. After that, determination of energy of electron when it is in stationary state. Hii hapa formula aliweza kuiderive Bohr. Lakini toka hapo Bohr atomic model explained the stability of an atom. Kwa sababu alisema kwamba electron will revolve in its orbit mpaka absorb au release energy ndio ita change orbit. Hiyo nayo pia alifanikiwa kuisema bwana Bohr. Lakini from there Bohr concept of atom explained successful the atomic spectrum of hydrogen. Tumeshasema hiyo. Then maana yake according to Bohr tuna ground pamoja na excited state. So when an electron jumps from the excited to the ground state, it releases energy, and that energy can be observed in the electromagnetic spectrum. So tukitumia prism ile energy, tunakuwa kabisa tunaona spectrum. Lakini pia we have shortcomings, yani mambo ambayo na yeye alimshinda, ambayo ya kwanza, the model could not explain the spectra and the energy of atoms containing more than one electron. Aliweza kuelezea hydrogen spectrum ambayo ina electron moja. Alishindwa kuelezea kama atom ina electron mbili au zaidi, multi-electronic atoms, spectrum yake itakuwaje? Alishindwa kuelezea hii. Number 2, no justification was given for the quantization of angular momentum of electron. So alisema kweli the angular momentum of electron in its orbit is quantized, lakini alishindwa kutoa maelezo. Na hiyo angular momentum of an electron in its orbit is quantized. Yani MVR is equal to NH divided by 2 pi. Ametumia kuderive mambo mengi sana kwenye theory yake. lakini alishindwa kutoa maelezo ya ziada kuhusu hiyo. Lakini toka hapo Bohr idea of orbital assumed that the electron in an atom was located at an infinite distance. Aliassume electron in an atom was located at infinity distance from the nucleus, and its velocity was also definite. So these ideas were proved wrong by Heisenberg uncertainty principle. Kwa huyu yeye Bohr alisema kwamba aliassume electron iko kwenye distance fulani from the nucleus, lakini pia alisema velocity ya hii electron inajulikana. Sasa kulingana na Heisenberg uncertainty principle akasema no, it's impossible to determine accurately and simultaneously the position and then the position of an electron and the velocity, position and a momentum, but momentum comes from velocity. Maana ukishindwa kudetermine velocity utashindwa kudetermine momentum. Sasa maana yake Bohr hapo alikuwa amefeli. Heisenberg uncertainty principle imekuja kusema he was not correct. From there, number 4, Bohr atomic model could not explain about the splitting of spectral light in a magnetic or electric field. We will discuss later about a Zeeman effect and a Stark effect, which are the splitting of spectral light. When you subject spectral lines in a magnetic or electric field, they are splitting, zinagawanyika. But Bohr failed to explain why so. Number 5, Bohr model doesn't explain about the shapes of molecules. And number 6, it couldn't account for the brightness or relative brightness of spectral lines. Baadhi ya spectral lines zinaonekana kuwa bright kuliko nyingine. Why? It couldn't account. Lakini number 7, he was challenged by Heisenberg that it is impossible to determine both velocity and the position of the moving electron at the same time, as we have said earlier. So this marks the end of our discussion about the Bohr atomic theory, and after this session we will start discussing about hydrogen spectrum, discussion about electron transition, and then we are joining the discussion about the electron transition with the discussion about the hydrogen spectrum. So let I wish you nice studies. This marks the end of our session. If you heard some of the facts about the hydrogen spectrum, in the next session, the whole session I will be explaining about the hydrogen spectrum only. I know the session will be somehow longer because of many things we need to discuss in the hydrogen spectrum. But I hope you enjoy the session and everything will go well. Thank you everybody, and let I wish you nice studies. Don't miss the next session.